How do you identify the hypotenuse, the opposite, and the adjacent sides in a right-angled triangle? Well, a lot of my students seem to have found it quite difficult when I give them a triangle like the one shown on the screen here, which has all the angles shown. It gives them a bit of a dilemma. Most of my students seem to have been taught at school that the hypotenuse is the longest side. So in this triangle, it's this side here. So they seem to be able to locate that quite easily and label that as the hypotenuse without too much of a problem. But what about then if I say which side's the opposite? Well, because I've labelled all of the angles, and I've given you all of them, most students seem to have a bit of a problem working out which side is the opposite. Is it this one over here, or is it this one down here? And the way to think of it really is it's very similar to how you find opposite things in real life, in everyday English, I should say. If I draw a table like this, and imagine we're looking down on the table, so this is the view from above. If I'm sitting over here and you're sitting down there, if I say to you which side of the table is opposite, you might say, well, it's that side there. But I might say, well, hang on, no, that side's opposite you, but opposite me is that side there. And we'd both be right, really. Neither side is particularly opposite. What's true is that that side is opposite you, and that side is opposite me. And lots of students, for some reason or other, don't seem to have quite understood that idea that it's exactly the same in trigonometry. So there isn't a particularly, there isn't a particularly opposite side of this triangle. It's just that this side over here is the opposite of 30 degrees, whereas this side down here is the opposite of 60 degrees. And we can also say that this side next to the 60 degrees is adjacent to the 60 degrees, and similarly this side next to 30 degrees is adjacent to 30 degrees. So if you haven't heard of that word before, adjacent just means next to, and just like opposite, no side is particularly adjacent, it's it's relative to the angle. So one side is adjacent to the 30 degrees, the other side is adjacent to the 60 degrees. And we also tend to encounter the same problem, say for example, if we're talking about the trig ratio. So for example, if I talk about sine, we're often taught in schools, it seems, that sine is equal to opposite over hypotenuse. And it's kind of true, but it's not really enough. It's the sine of an angle is equal to the opposite of that angle divided by the hypotenuse. So in this case, if I wanted to find out the sine of 30 degrees, that would be equal to the opposite of 30 degrees divided by the hypotenuse. But if I wanted to find out the sine of 60 degrees, that's equal to the opposite of 60 degrees divided by the hypotenuse. So in one case, I'd be dividing this length here by the hypotenuse. That's the top one, sine 30, because that flashing side there is opposite the 30 degrees. But if you want to work out the sine of 60 degrees, then that's going to be this side, because this is the side that's opposite the 60 degrees. So it's not just sine is opposite over hypotenuse, and cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. The opposite and the adjacent depend on which angle you're trying to find the sine of, the cosine of, or the tangent of. Hope that's been helpful, and look forward to teaching you again.